This is Prashant, Faculty of Physics from Alpha Exodus. Today we are going to discuss about Doppler effect in a circular motion of a body. Doppler effect in a circular motion of a body, that is maybe source of a sound or observer in motion. If source of a sound is in motion, observer is at rest at its center. If observer is in motion and the source of a sound is in rest at its center, what is the Doppler effect identified by the observer? Now we are going to study. According to given, source of a sound rest at the center and observer in motion. Source of a sound S is at rest at the center of a circular path. At the center of a circular path of radius R. And observer in motion. Observer in motion. The radius is R. Now, at this point, the motion of the observer is a tangent. At this point, motion of the observer is a tangent with the velocity of a v0. And at an highest point, motion of the observer with the velocity of a v0 in a tangent. Similarly, at the point with the velocity of a v0, at this point with the velocity of a v0. So, observer is moving in a anti-clockwise direction with the velocity of a v0 with the radius of r. Similarly, in second case, observer is at rest at a point O with the radius of R. Source is in a circular path. Source is in a circular path of radius R. When source is in a circular path of radius R in anti-clock direction, at this point, then its motion is tangential with the velocity of Vs. And at an extreme point or a highest point, its direction of a velocity Vx. And then the next point, it to travel with the velocity of Vs. Similarly, we consider another point. Here its velocity is Vs. In these two situations, what is operant frequency? What is operant frequency observed by the observer? Operant frequency in first situation and operant frequency in second situation. Come to the first situation. Here, angle subtended by the observer with velocity vector is theta naught, that is equal to right angle 90 degrees. Therefore, operant frequency observed by the observer n dash is equal to n into v minus v naught cos theta naught is divided by v minus vs cos theta s, that is equal to n into v minus v naught cos theta naught is equal to 90 degrees is divided by v minus vs, source of sound is at rest, and cos theta s. So 0 into something is equal to 0. This total term is 0. Cos 90 is 0. 0 into V0 is 0. That is equal to operant frequency observed by the observer is n. That is V by V is equal to 1. Therefore, operant frequency observed by the observer n dash is equal to natural frequency or fundamental frequency n. It means there is no Doppler effect between source of a sound and observer in the first situation. In second situation, velocity vector and radial vector angle between them as 90 degrees. Therefore, theta s is equal to 90 degrees. Then operant frequency n dash is equal to n into V minus V naught cos theta naught is divided by V minus Vs cos theta s. That is equal to n into V minus V naught. Observer is at rest. 0 into cos theta naught is divided by V minus Vs cos theta s is equal to 90 degrees. Then 0 into something is equal to 0. Cos 90 is 0 into Vs is 0. This total term becomes to 0. Then V by V is equal to 1. Therefore, operant frequency observed by the observer n dash is equal to its fundamental frequency n or a normal frequency or a natural frequency n. In this second situation, observer is at rest, source of a sound in a circular motion with the radius of r, then also he cannot identify any Doppler effect. Whatever may be, either source is at rest or observer is at rest. If source is at rest, observer is with the velocity of a V0 in circular motion of a radius r, there is no identification of a Doppler effect. Vice versa, if observer is at rest, source of a sound in motion with the radius of r, then there is no identification of a Doppler effect. That means the operant frequency must be equal to the natural frequency of a source of sound. Thank you.